Pogo sticks date back to 1919 when they were first used as a popular pastime in Germany. They were invented by two men named Max Pohlig and Ernst Gutschall. When you combine the beginnings of their last names, Pohlig and Gutschall, you get Pogo, hence the name Pogo stick. Since then, Pogo sticks have been an enjoyable activity for people of all ages, but they definitely do require some skills and understanding of physics. Here are some videos of people who don't necessarily have those skills. Pogo sticks are powered by a spring, compressed air, or elastic bands. In this video, we will focus on spring-powered sticks, which perfectly demonstrate the concept of Hooke's law. When an object can be stretched and then returned back to its original state, Hooke's law applies. Hooke's law states that the restoring force is always proportional to the amount of stretch. The stretch is the amount that the pogo stick spring is compressed or stretched from its equilibrium, and the restoring force is the upward force exerted on you when the spring is compressed. The restoring force wants to return the pogo stick to equilibrium, which is the point where the spring is neither stretched nor compressed and is not in motion. The spring pogo stick follows Hooke's law.
Your mass affects the amount of mass in the equation F equals ma. As demonstrated by the equation, the more mass you have, the more force will be exerted upon landing. Thus, the more mass you have, the higher you will jump. Kinetic and potential energy are utilized by pogo sticks. When the spring of the pogo stick is fully compressed, all of the energy is potential energy. When the spring is compressed or extended, both gravitational potential energy and kinetic energy from the movement are present. As the spring changes from one of these scenarios to the other, potential energy and kinetic energy are converted back and forth. Moreover, there is a split second when the spring is fully extended at the top of the hop, when all of the energy is potential and the pogo stick isn't moving. As the pogo stick starts to move back toward the ground, the potential energy is converted into kinetic energy once more. When the pogo stick hits the ground and the spring compresses, potential energy is generated again. This cycle of potential energy and kinetic energy is repeated until the pogo stick stops. To summarize, here are the steps for energy transfer. Step 1. All the energy is elastic potential energy, while the pogo stick is on the ground. Step 2. Just after leaving the ground, all the energy is kinetic energy. Step 3. The energy is half kinetic and half gravitational potential energy. Step 4. All of the energy is gravitational potential energy because the pogo stick is at its highest point, so it stops for a split second. Step 5. Energy is half kinetic and half gravitational potential energy. Step 6. Just before hitting the ground, all the energy is kinetic energy. Finally, Step 7. The pogo stick returns to the ground and all the energy is elastic potential energy. Also, don't forget that some energy is dissipated into the ground with each jump.
The more force you exert on the pogo stick, compressing the spring, the more upward force will be exerted back up on you to return the spring to equilibrium. The equation for Hooke's law is F sub s equals negative kx, where F is the force applied to the spring either in the form of strain or stress. X is the displacement of the spring with a negative value demonstrating the displacement of the spring once it is stretched, and K is the spring constant, which details just how stiff the spring is. The negative sign in the equation is an indication stating the direction the spring stretches is opposite the direction of the force the spring exerts. For instance, when the spring is stretched below its relaxed position, X is downward. The spring responds to this stretch by exerting an upward force. The X and F are in opposite directions. Furthermore, the spring constant is a positive value that is dependent upon the spring which is being studied. A stiff spring would have a high spring constant. This means that it would take a relatively large amount of force to cause a small displacement. The units for the spring constant are Newton meters, because when K is isolated in the Hooke's law equation, it is found that K equals negative F sub s divided by X. F is measured in newtons and X is measured in meters. It is notable that the equation for Hooke's law works for springs stretched vertically and for springs stretched horizontally.
So why do these fails happen? It is important to properly distribute the forces discussed above while landing on a pogo stick. Often, dangerous accidents happen as a result of a bad landing angle. An angle of 90 degrees ensures that your pogo stick will go straight back up in the air. Otherwise, balance will be disrupted. Balance is defined as an even distribution of weight enabling someone or something to remain upright and steady. Landing at an odd angle will not distribute the weight of you and the pogo stick evenly, and thus, you will fall. In other words, if the landing angle is too acute, the person will most likely fall due to the uneven distribution of force and the disruption of balance. In addition, if the person's weight isn't directly over the pogo stick during the landing, the person is likely to fall off. There are two masses in the pogo stick system, the pogo stick and the person. If these two masses do not work together, then a fail is likely to result. Performing tricks on the pogo stick has become increasingly popular in the past few decades. However, most people do not understand the physics behind this phenomenon and often fail as seen earlier. If Hooke's law is not understood, and the person performing the trick doesn't exert enough force in order to execute the trick, then they may fall or be unable to fulfill their desired intent, such as a successful dismount. If the person doesn't have enough energy to dismount the pogo stick and flip, they will most likely injure themselves. If a person desires to have enough airtime to perform a stunt or trick, they must exert enough force on the pogo stick and ground in order to launch themselves up into the air to the necessary height. As stated earlier, the more the spring is compressed, the more energy will be stored as potential energy in the spring. As the spring transitions from compressed to stretched, the energy will be converted to kinetic energy, which will aid in propelling you into the air. It is important to keep the equation F equals ma in mind. You will most likely be exerting a greater force if you have a greater mass. Therefore, you should be aware of your mass and your acceleration. Too much force could potentially break the pogo stick and consequently cause you to fall.